Class, this is Mrs. Groves, and today we are starting a new chapter, and we are going to be covering polynomials. And polynomials is just a fancy word for an expression. This section right here is going to be very vocabulary intensive, so you may want to just listen to me and then pause and write the notes down, and then listen to me and write the notes down. So here we go. Now these should be a little bit of a review for you. Factors are the parts of an expression separated by multiplication. So in this example, we have negative 3xy squared. That means that we have three factors. We have two implied multiplications. We have negative 3 times x times y squared. So we have three factors. Terms are the parts of an expression separated by addition or subtraction signs. So here we have 1, 2, 3 terms. And notice that the terms include the sign. So here's our first term, our second term, our third term. And I think you're already pretty familiar with terms. So now we are going to call a term that is only one term a monomial. A monomial can be a number, a variable, or a product of numbers and variables. So for example, a monomial, which is one term, could be 5 or x or negative 2xy. Each of these are one term. Hence the name monomial. This is a new definition. A polynomial, poly means many, is a sum of monomials. So this right here is called a polynomial. And a polynomial is just like an expression typically. There are some rules. So we have this polynomial. It's got three terms. So, what are the rules? Polynomial can only use operations of addition, subtraction, and multiplication. A polynomial cannot have variables in the denominator, variable exponents, and negative exponents. All right? An easier way to understand the definition of a polynomial at this point in algebra is to understand what is not a polynomial. Okay. Oops. Here are some examples of what are not polynomials. Okay, the square root of x. All right. The only operations are addition, subtraction, multiplication. The absolute value of x, for the same reason. 4 divided by x. Well, we can't have division and we can't have variables in the denominator. 5 to the negative x. We can have x as an exponent. We can have negative exponents. But this is a polynomial because x is the same thing as 1/4 times x. All right? So x over 4 is really 1/4 times x. So that is a polynomial. Now we're going to go over, well, what happens if we have two terms? Well, two terms If we have two monomials, it's called a binomial. Two terms. A trinomial is three terms. So here we have three terms. So you need to know monomial, binomial, and trinomial. If it's more than three terms, you just need to know it's a polynomial with however many terms there are. Now, degree of a polynomial with one variable is the highest exponent in a polynomial. Right? So here we have our x squared plus x plus 1. The degree is 2. Right? We take the highest exponent. So now the degree gives us another way to name our polynomials. So a linear polynomial has a degree of 1. So x plus 1 is a linear polynomial because there's an implied 1 here. The degree is 1. So this is called a linear binomial. Okay, quadratic. The degree is 2. So here's an example, x squared plus 3x plus 3. And the degree is 2. So this is called a quadratic trinomial. You should also know cubic. Okay. The degree is 3. So we have 2x cubed plus 5x squared. The highest exponent is 3. So this is a cubic binomial. Now, another way to do this, and if you go to the back of your handout, is to put it in two charts. Okay. We're going to set up two charts. We're going to name our polynomials by terms, and we're going to name our polynomials by degree. And I think this will make it simpler for you. So let's start with terms. Okay. If it's one term, it's called a monomial. If it's two terms, it's called a binomial. 3 terms is a trinomial. And anything after 3, you don't have to memorize the name. It's a polynomial with n terms. So if you have 7 terms, it's a polynomial with 7 terms. Okay? Monomial, binomial, trinomial, the number of terms. Now, degree. We'll go back to the 0 one in a minute. So remember, we're going to have degrees 0, 1, 2, 3, and n. If the degree is 1, it's called linear. And we've been doing linear equations all year long. If the degree is 2, it's quadratic. If the degree is 3, it's cubic. And if it's more than 3, it's a polynomial to the nth degree. So if the degree was 8, it would be a polynomial to the 8th degree. Constants. Constants always have the degree of 0. The number 5 is a constant, and the degree is 0. Why? Because we did exponents last chapter. If we have 5x to the 0, x to the 0 is 1. 5 times 1 is 5. All right. So now let's go back to our handout on the front page. Okay. And we are doing example number 1. Remember? Okay. Polynomials are equal to expressions. Right? And it says write this polynomial so that the exponents decrease from left to right. Right? So that's the first thing we're going to do. We're going to take this polynomial and we are going to basically write in standard form. Right? In standard form, we want to do that so that we don't get ourselves confused when we are going through problems. And if we just did it any old way, then someone might have an answer like this, and someone might have the negative 4x first. But we're going to write, always, we're going to go from the high to the low exponent. So that means that we're going to write this as 2x to the 4th minus 4x plus 7. And if we had variables, like if this was x and y, then okay, we put in A, B, C order. So if we had x plus y plus 2, we want to have it go in alphabetical order. Now, we're not going to get too worried about when it gets complicated if we have alphabetical x and y and with a combination of exponents. At this point, I'm not going to do that to you. And this is a 2, or it could have been a z. So the next thing we want to do is identify the degree. So think to yourself, what is the degree of this polynomial? Well, the highest exponent is 4. So that's the degree. Okay? So the degree of this polynomial is 4. And the leading coefficient is exactly what it says. If we have this in standard form, there's going to be the leading coefficient. So the leading coefficient, okay, is the one that's in front. That's a 2. There's a lot of definitions in this section. So here are a few checkpoints. So the first thing I want you to do is take these two polynomials and write them in standard form. Then I want you to tell me what the degree is for each, what the leading coefficient is for each, and what the constant is for each. So pause the video, do these two problems, and then when you're ready, come back and see if your answers match with mine. So pause. I'm going to be working on these. Okay, so we want to put this in order, high to low exponents. So this is 8x cubed plus 5x plus 13. The degree is the highest exponent, so it's 3. The leading coefficient is the one at the beginning, is 8, and our constant is just simply our number, 13. So in the next example, make sure that you take your sign with you. So this is negative 7y to the 5th plus 4y to the 4th plus 2y. The highest exponent is 5, so the degree is 5. The leading coefficient, don't forget this is negative. It's negative 7. And we don't have any constants, so there's none. All right, so now we want to identify which of these expressions are polynomials, right? And explain why. So we're going to go through this twice. Is this a polynomial? Well, yes, because this is basically negative 6 times 1, so that's a polynomial. Is this a polynomial? No. It's got a negative exponent. Right? Here, right? This is basically an expression. There's nothing unusual, so yes, that's a polynomial. Okay. Here, again, there's nothing unusual here, so yes, this is a polynomial. Here, do you see anything unusual? Well, we can't have w as an exponent, so this is, no, it's not a polynomial. Okay? It's got a variable for the exponent. So, for the ones that are polynomials, A, C, and D, we're going to classify them, okay, by degree and by terms. Okay, so here, this is, the degree is 0. Okay, and this would also be equal to negative 6. Either one of these, that's a constant. And there's only one term, monomial. All right. Here, the degree is 3. 3 means that it's cubic. 2 terms, binomial. Okay, here, the degree is 4. Okay, and we have 3 terms. So this is a trinomial. Okay, to the 4th degree. So now I want you to do these 2 checkpoints on your own. you're going to tell whether it's a polynomial or not a polynomial. So, is it a polynomial or is it not a polynomial? If it's a polynomial, you're going to name it. So, pause the video. Right? And now I'm going to go through the answers. This is a polynomial. And this is a polynomial that has 3 terms. So that's a trinomial. Because I'm not going to make you memorize anything for a degree above 3. So this is a trinomial to the 7th degree. This one is not a polynomial. Okay? Why? Because we have a negative exponent. So that's a lot of definitions. But I think once you go through some practice problems, they're just going to make sense. And we are going to be talking about these for the rest of the year. So now we're going to go to something a little bit easier. And we're going to add and subtract polynomials. Okay. Well, adding polynomials, you're just basically grouping like terms. So let's just do this for a mental step. Right? And start with the highest exponent. So we look at these and we're going to have x squared plus x squared. And then we have our x's. So that's x minus x. And we have our numbers 8 minus 1. So mentally you're saying to yourself, we're going to combine these like terms, these like terms, these like terms. Now you'll never have to show that work. That's what you're doing in your head. So I'm going to end up x squared and x squared. Remember, for like terms, we simply add the coefficients. And the coefficients here, we have a 1 and a 1. So this is 2x squared. X squared minus x squared, that cancels out. 8 minus 1 plus 7. So now, before we go to subtraction, I want you to do this one yourselves. And so, just add this. You don't have to show any work. Try to do it yourself. Pause it for a second, and then come back and I'll show you the process. So when we add, we're basically ignoring the parentheses. So we look for our highest exponents. We got 3x to the 4th, 9x to the 4th. That gives me 12x to the 4th. Okay, do I have any cubes? No, no cubes. And don't scratch them out because that'll make it very difficult for you to check your work. So then I see, okay, I do have a cube right there. Plus 5x x cubed. And I usually put little underlines to make sure that I get all my terms. And then here, so here we go. And so we have negative 2x squared and negative x squared. So negative 2, and that's a negative 1. Negative 3x squared. And we have a negative 1 here, minus 1. And that is your answer. Now we're going to be subtracting this polynomial. So we have this polynomial, we're going to subtract it. Now you're going to get yourself really confused if you just try to do this mentally. You want to rewrite as an addition problem. And I'm going to expect you to do that when you do your homework or you take a test. All right? So the first thing we do is this one, we don't do anything. We just write that down. 3x squared plus 6x minus 4. Now, we can either take the opposite or we can take this and we're going to distribute negative 1. Okay, because that's going to make this positive. And we are now going to take the opposite, negative 1 times x squared minus x squared, negative 1 times negative x, plus x, negative 1 times negative 7, plus 7. Right? And now it's really easy to add these. And so you just look for your highest exponents. You're going to get 2x squared. Then you look at your x's, plus 7x. You look here, plus 3. And boom, you're done. And we did that problem up there, so we don't need to do it. I think it makes it easier to just show it that way. So now we have one last problem to do. So I want you to try to do it on your own and put this on pause and then come back and see if you got it right. All right, I'm going to rewrite this as an addition problem. So 3t squared minus 5t plus t to the 4th. I'm going to distribute negative 1. So this is going to be minus 11t to the 4th plus 3t squared. I'm now going to combine like terms by adding the ones starting with my highest exponent. So 1 minus 11 gives us negative 11t to the 4th. Add these, plus 6t squared minus 5t. And that's it. Oops. That's negative t to the 4th. That's 1 minus 10, negative t to the 4th, plus 6t squared minus 5t. Right, that ends this section on 9.1. Have a great day.